Sets are simple data structures, and they have one main use: collecting unique elements. Our next data structures, dictionaries, are more flexible. Rather than storing single objects like lists and sets do, dictionaries store pairs of elements, keys, and values. In this example, we define a dictionary where the keys are element names and their values are their corresponding atomic numbers. We can look up values in the dictionary by using square brackets enclosing a key. We can also insert new values into the dictionary with square brackets. Here, we are adding lithium and giving it a value of 3. Dictionary keys are similar to list indices. We can select elements from the data structure by putting the key in square brackets. Unlike lists, dictionaries can have keys of any immutable type, not just integers. The element dictionary uses strings for its keys. However, it's not even necessary for every key to have the same type. We can check whether a value is in a dictionary the same way we check whether a value is in a list or set with the in keyword. We can use in to verify whether a key is in the dictionary before looking it up, if there's a possibility that the key is not there. Mithril was not part of our elements dictionary, so false is printed. Dictionaries have a related method that's also useful: get. Get looks up values in a dictionary, but unlike square brackets, get returns none, or a default value of your choice, if the key is not found. The lithium is not in our dictionary, so none is returned and then printed. If you expect lookups to sometimes fail, get might be a better tool than normal square bracket lookups because errors can crash your program, which isn't good. You can check if a key returned none with the is operator, or you can check for the opposite using is not. These are called identity operators. You will learn more about identity operators and how they differ from using these equals to or not equals to comparison operators in the quizzes that follow.